Dear students, today we are going to see about quantitative methods for business. Simplex model with unrestricted variables we are going to solve now. Already we have solved the questions with respect to the basic models. If you don't watch that video, please go back and watch that video. We are going to have the same ideas here with a little bit modifications. I am Dr. C. Sudhakar with you. Let us take a sample question. Solve the following linear programming problem by simplex method. Maximize z equal to 5x1 minus 10x2 subject to the conditions. These are the constraints given to us. So it looks like a very simple question with two variables. Naturally for anyone it will give you a temptation that we can solve by graphical method, but it is not possible to solve by graphical method. I will tell you the reason why. So before start solving the problem, let us check the conditions of the linear programming problem. So we will check whether it is in the standard form. First thing is we should check whether the function is maximum or not. Okay, so look at this place. The function is maximum or not. Okay, so check the objective function. Here it is maximum, so no need to change required for the objective function. In case if it is a minimization function, something like this, minimize z equal to something like 4x1 plus 5x2, multiply the equation with a minus, so minus 4x minus 5x2, take it as a new function, maximize z. Okay, so it is maximize new z dash. Okay, this is how we can convert a minimization problem into a maximization problem, but here it is not required for us because it is already a maximization problem. Now let us start checking the second condition here. Second condition is we should check for the right hand side coefficients. The right hand side coefficients are all positive numbers like 60, 72, 19, all of them are positive numbers here. This is the right hand side coefficients, all of them are positive. In case some of the constraints are negative, something like this, if you are having 4x1 plus 5x2 less than or equal to minus 4 means negative term into a positive term by just multiplying the complete equation with a minus 1. So this will come minus 4x1 minus 5x2 minus 4 into minus. When you are multiplying an inequality with a negative number, you have to change the sign. So this will come greater or equal to 4. Now the right hand side was brought into a positive number. So that is the second condition we should check. So but here it is not required because all the constants here on the right hand side are positive numbers, 60, 72, 19. Now let us check for the third condition. What is the third condition? Third condition is check all the variables are non-negative. So here in the question it is given x1 is greater than or equal to 0, but they don't give any information for x2, which means x2 is unrestricted. Unrestricted means it can be any number like positive number or negative number, or even it can be 0 also. In some questions it will be given explicitly like x2 is unrestricted. In some questions it will be left out without any information. So you should understand that x2 is unrestricted. If a variable is unrestricted, first we should convert this into a restricted variable. So how to convert this? If your x2 is unrestricted means use this equation, introduce two variables x3 and x4 with this relation x3 minus x4. So replace the x2 by x3 minus x4. So where this x3 and x4 will be a positive number. Listen to that. When we are having 7 minus 5, it is a positive number. If you are taking 8 minus 12, that is going to be a negative number. So this is our x2. x2 can be a positive number or negative number, whereas this x3 and x4 will be definitely a positive number. 7 is a positive number, 5 is a positive number. In between we are having minus. In this case x3 is 8, x4 is a positive number. So we are getting a negative number. So this is the logic behind this equation. Whenever a variable is unrestricted, so x2 is unrestricted means always replace the x2 with two new variables x3 minus x4. Now the next step we will apply it. So we will replace all the x2 by x3 minus x4. This x2 is replaced by x3 minus x4 and this x2 is replaced by x3 minus x4. Just in the place of x2 replace with this. So the next equation is coming 4x1 less than or equal to 72 and here there is a x2 in this third equation minus 7x2, it will be replaced by x3 minus x4 less than or equal to 19. Now all the three variables in this equation are non-negative. x1, x3, x4, all of them are non-negative. That means the third condition is also satisfied. All the variables are non-negative now. Now the next step, we are going to convert the inequalities into equations. So how to convert it? By the same method what we used in the simplex method. Whenever a number is less than some other number, we have to use a slack variable here. 7 plus s1 equal to 12. Okay. So the slack variable can be any positive number greater than 0. Now let us convert all the inequalities into a equation. Convert the inequalities into equations by introducing a slack variable, surplus and artificial variables. Okay. Now the first one does not require any surplus or artificial variables. The second one is as an inequality. So this less than or equal to was replaced by plus s1 equal to. Okay. So it becomes an equation now. Now coming to the next one, 4x1 less than or equal to 72, though again we use the same logic here, less than or equal to was replaced with plus s2. Now the third equation is again we are introducing a new slack variable s3. Now all the variables whatever we have s1, s2, s3, all of them are greater or equal to 0. So fourth step is also completed. We have converted all the inequalities into equations by introducing these variables s1, s2, s3. Now let us arrange all these constants into a uniform format. Okay, so that means we are going to arrange them in a system of equations. First let us introduce all of them are x1 at the first level, so 3x1, so here it is 3x1 minus 5x4 minus into minus 5 plus 5x5, so therefore minus 5x3 plus 5x4 s1. Now here there is no s2 here, but here there is an s2, here there is an s3. So what we can do is whenever there is a variable is missing, we put 0 s2, 0 s3 equal to the right hand side number 60. So this equation was rewritten like this in the format, first all the equations coming x1s, x1, x1, x1 and then x3, 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 x4, x4, x4 like that we have arranged it. Then I am going to make a small change for this objective function. The objective function bring all the variables to one side and keep the right hand side equal to 0. Now 5x1 minus 10x3 when you are bringing to left side, it is going to be z minus 5x1 minus 10x3 when you brought to left side, this minus 10x3 when you are coming here, it is going to be equal to plus 10x3. So plus 10x3 minus 10x4 plus 10x4 was brought into minus 1 plus 0 s1, s2, s3 equal to 0. So we have converted the objective function to the left hand side. Now let us, this is called the canonical form. We have arranged all the equations in the proper order. Now we are going to start processing the solution. First we should put a table. Okay, in this table always start with the slack variables s1, s2, s3 and z is the objective function variable. So these are the basic variables for us. This S1, S2, S3 is called the initial basic feasible solutions. Okay. Now here according to the equations, okay, so here x1, x3, x4, s1, s2, s3 is there, so we will fill up them now. So this is called the right hand side constants. So whatever the constants coming here, we are going to fill up in this column. So therefore this is RHS. RHS means it is right hand side. So let us take the first equation, 3x1 minus 5x3 plus 5x4 s1 0 s2 s3 equal to 60. Take only the numbers. The numbers here are, this is 3 minus 5 plus 5 plus 1 0 0 60. Okay, take these numbers and put it in the first row. Now take the second equation, 4x1 0 x3 0 x4 0 s1 plus s2 s3 equal to 72. Put the constants here. Okay, take along with this symbol. Then take the x3. x3 is having 0 minus 7x3 plus 7x4 0 0 1 19. Okay, so here there is a minus 7, so you should take it along with this sign. It is going to be 0 minus 7 7 0 0 1 19. Now take the objective function. The objective function is z minus 5x1 plus 10x3 minus 10x4 0 0 0. So you put this is equal to 0 actually, but we are not going to take the right hand side constants now. So fill up the constants. So the first term is a minus 5, so it is coming minus 5 plus 10 minus 10 0 0 0, and here we are not going to fill up anything now. We will see in the last step the equation into the table. Okay, so we put all the values here. Now we are going to start process this table. Minus 5, minus 10. These are the two places we are having the negative numbers. Look at only this row. Look at only this row. Here we are having the negative numbers minus 5, minus 10. Out of the negative numbers, choose the most negative number. What is the meaning for most negative number? So minus 5, minus 10, forget about the symbols, choose the bigger one. That is called the most negative number. If you are having 7 and 20, minus 7, minus 20, 14, don't take the positive numbers, see only the negative numbers. In the negative numbers, remove the negatives, and 7 and 20 choose the bigger one. Okay, so this is called the most negative number. So likewise, first you should choose where you are getting the most negative number. After getting the most negative number, this one, this column, mark it. This we are calling it as the pivot column. So this variable x4 is going to enter in the next iteration. Okay, so we are going to improve the x4 in the next step. Now after finding the pivot column, now come to the last column. So find what is coming in the ratios. So the ratio formula is RHS divided by ECE. ECE means entering column element. So entering column element. So this is the entering column, and these elements are called entering column. Find the ratio. Take this 60 and divide it by this 5, that is going to be equal to 12. Then 72 divided by 0. Whenever you are getting a negative number or an infinity number, don't write it here. Simply you can put a hyphen. Okay, 72 divided by 0 is infinity, so I am not writing, just leave it empty. Then third one is 19 by 7. 19 by 7, the value is 2.7. Okay, the last one we are not going to find anything because it's a negative value. Now look at these three values only now. 12, some value, and 2.7. Here nothing is there, don't worry about it. So out of these three values, choose the small one. Okay, now mark this row. Mark this row. This row is called pivot row. This row is called pivot row, and this column is called pivot column. Okay, so the pivot row, this variable we are going to remove it. S3 we are going to remove it. In the place of S3 we are going to put X4 in the next step. This is the pivot element. This X4 will be replaced by this S3. Okay, so take out this S3 and put X4 in the place. Now we extended the table. Okay, so this element, pivot element, is a very important element for the next iteration. Our first calculation is we are going to calculate this S4. We are going to use a separate formula for this X4, and for other rows, this S1, S2, Z, we are going to use another formula. So two formulas we are going to use it now. First, let us see how to calculate these numbers. To calculate this row, this is called the new pivot row. New pivot row. Okay. So for new pivot row, take the old pivot row elements. Okay, from here, because we are changing this S3, no. So this is called the old pivot row. From the old pivot row, take the numbers. Now apply this formula, new pivot row equal to old pivot row divided by pivot element. What is a pivot element? This pivot element is 7 here. Okay, so we are going to take the old pivot row. This is the old pivot row. Now we are going to divide by the pivot element. Pivot element is 7. So divide all the numbers. 0 by 7, minus 7 by 7, 7 by 7, 0 by 7, 0 by 7, 1 by 7, 19 by 7. So these are the values for us. Now substitute this in the row X4. Okay, put these values in X4. This is called the new pivot row. So new pivot row. What is the thing we have done? New pivot row is equal to old pivot row divided by pivot element. Okay, so this is what we have done now. Now all other three rows we are going to form a new formula. Okay, so once you have done the calculations correctly, this pivot element in this place you will get a 1 here. So that is a checkpoint. Okay, you can just verify that always you will get it 1 here. Now let us take the Z row, last row. Okay, any order we can do it, it doesn't matter now. So I am taking Z now. Now for this row I am going to use a new formula. New row equal to old row plus minus of pivot column element into new pivot row. So this is the formula I am going to use for this row S2 and S1. So new pivot row is a different rule and other three rows are having this same rule. So now let us take what is the pivot column element, what is the new pivot row. For the entire three calculations, hereafter we are going to use this row. This is the new pivot row. Now take the elements from the new pivot row. Pivot column element is minus 10 now. Okay, so minus 10 is the pivot column element. Now change the symbol. Here it is minus 10, so I am going to multiply it by plus 10. Minus of pivot column element. So minus pivot column element is minus 10, minus of pivot column element is plus 10. Now take the pivot row elements. This is the new pivot row elements, 0, minus 1, 1, 0, 0, 1 by 7, 19 by 7. Multiply all of them by 10. So when you multiply all of them by 10, you get 0 into 10 minus 1 into 10. So just multiply them. This is going to be the answer for us. 0, minus 10, 10, 0, 0, 10 by 7. So what are things we have done? We have taken the new pivot row and we multiplied by the pivot column element. Now you should add it with the old row. Where is the old row? So this is the old row. Okay, so this is the old row for us. Now you should add this numbers with the numbers of this row. Okay, so let us take and put it here. So this calculation you can do it in a rough sheet. Okay, as a rough work. Separately you can do it and you can fill it in the table. Just for your understanding, I am putting it here. Okay, minus 5. So add all these values So minus 5, 0 is minus 5, plus 10 minus 10, 0, minus 10 plus 10 is 0, 0 plus 0 is 0, 0, 0 is 0, 0 plus 10 by 7 is 10 by 7. Now take these elements and put it here. Okay, take these elements and put it here. So we have done the calculation for this Z row. Now after calculating this, the same method will apply for the S1 and S2. Okay. One more thing you should note it. So this number in the previous step it was converted into 1. After applying all the rules, this place will become 0 in all the questions. So this is another checkpoint for us. So likewise our aim is to make the pivot element as 1 and all the numbers in the same column you should make it 0. How to make it 0? For that we have given the rule. What is the rule? Take this new pivot row and take the old row plus minus pivot column element into new pivot row. So that is the rule. When you are applying this rule, these two places will come 0. Okay. Now let us calculate this S1. So what is the old row for S1? This is the old row for S1. So I am writing this. What is the rule we have used here? So this new Z is equal to old Z plus we have taken the 10 into this new pivot row x4 new. Okay. Now same thing we are going to do it here. So what is the rule we are going to use it here? The old S1 row, the new S1 row will be given by take the old S1 row plus negative of the pivot column element. Okay, what is the pivot column element? Here it is plus 5. So I am going to put it as minus 5 into new pivot row. New pivot row is x4 new. Okay, so this is x. Let us take the number from here, old row, take the values from old row, multiply it by minus 5. When I am multiplying it by minus 5, we get these values. Okay. Now we can go and add it with the old row. So this is the old row. We take these values and we can add these two values now. Okay. So all the values we will add it now. So 3 plus 0, minus 5 plus 5, 5 plus minus 5, 1 plus 0 is 1, 0, 0 is 0, 0 minus 5 by 7 is minus 5 by 7, 60 minus 95 by 7 is this value. Okay, use the calculator and don't write it as a decimal, put it as a fraction like this. That will give the exact answer for us. Now this element we take and put it here. Okay, so now 30010 minus 5 by 7, 325 by 7. Now, okay, so this is the calculation for the S1 row. Now coming to S2 row, if you look at that, this place is already 1. Okay, so this place is already 1. This was 0 now and this was 0 now and this also should be 0. But actually when you look at this column, already this is 0. Therefore, there is no need for any changes. Just to take this S2, okay, this new S2 is going to be the old S2. Same thing, no change. But when you are applying the rule, you will get the same thing plus the pivot column element into x4 new. What is the pivot column element? The pivot column element is 0 here. Therefore, you multiply it by minus 0. Okay. If you are applying the rule, we will get the same one. New pivot row, new row equal to old row plus minus pivot column element into new pivot row. So this is our old row. Now let us calculate this row. Therefore, take the values from here. Okay, so that row we are taken it 0 minus 1 1 0 1 by 7 19 by 7, multiply this with 0. So when you are multiplying with 0, change everything will become 0 for us. Now take the values and put it to old S2. Okay, so this is the old S2 value, add the values. Okay, so 4 plus 0 0 0 0 plus 0 0 plus 0 1 plus 0 0 0 72 0. Okay, or add all these values. When you are adding all the values, you get these answers. Okay. Now these values you can put it at S2. Okay, this place you can put it now. So finally what we have done, we have calculated all the values from here. So S1, so finally we have done all the values here. Now let us proceed to the next iteration. Okay, so how to know that this problem is over or not? To check whether the problem is over or not, check the Z row. Okay, so this row, if you are getting all the numbers are positive numbers, okay, all the numbers are positive, that means the process is finished. But what happens here, again we are getting a negative number here. If you are getting a negative number, that means it is still possible to improve the solution. Now let us take this negative number, because there is only one negative number, we choose this. If you are having again two negative numbers, sometimes it's possible you will get a negative number here, you will get a negative number here, you will get a negative number here. So out of all these three negative numbers, choose the most negative number, as same like in the first table. Now we are having only one negative number, choose this number. This is the new pivot column. Okay, so this is the new pivot column. So this is the new pivot column for us, because this is most negative number. Now again, once you choose the most negative number, what we should do, we should go here. Okay, so what happens here is this S3 was replaced with X4. Now what is the rule for this last column? The ratio will be calculated by right hand side constants, that is these numbers divided by the entering column element. So this is the entering column now. So this is the entering column elements now. We are going to divide it. First one, we can divide 325 by 7 divided by 3. Okay, so you will get 325 by 21. Next, take these two numbers, so 70 is going to be equal to 18. The third one I am not going to write it because it is giving infinity. 19 by 7 divided by 0 is infinity. I am not going to write it. So the procedure is going to be again similar. You know what we are going to do now. We are going to take these values, choose the smallest one. So which is the smallest one? 15.47 is the smallest one. That is going to be the leaving variable. Okay, so this is going to be the leaving row. This is going to be the leaving row, which means we are going to, S1 will be removed, then we are going to put X1 in that place. Remove the S1 and enter this X1. Okay, so correspondingly, wherever you are having the entering column, this variable will be entered here. That is going to be the next iteration for us. So once the procedure is done, then we are going to repeat the procedure for all the rows. Now the new row X1 will be calculated by, so first this is the new row. Now what happens, this S1 was removed and we got X1 here. Okay, but other elements are same, S2, X3, X4 all same. Now take this 3 and divide this complete row by 3. So that is a new row. X1 new will be equal to old X1 or S1 divided by 3. Okay, so this complete row is divided by 3. So you get a 3 by 3, that is 1. 0 by 3 is 0. 0 by 3 is 0, and this is 1. Divide by 3 is 1 by 3 here. 0 minus 5 by 7 divide by 3. Okay, so that is minus 5 by 7 divide by 3 is minus 5 by 21. 325 by 7 divided by 3 is 325 by 21. So we are filling it up here. Same we are going to apply it for the next two rows also. Okay, so X1 is done like this, and S2. So S2 the same row. Take the old S2 row and take the pivot column element. What is the pivot column element? 4 is the pivot column element. So take the 4 pivot column element, change this into minus 4 and add it with the new pivot row. So this is the new pivot row now. Add it with the new pivot row. So you get a new S2 now. So you see that this place has become 1 and this place are all coming 0, 0, 0. Okay, so the third row X4 new is going to be X4 0 plus 0 into X1 n. Why we are doing like that? because this place is already 0, there is no need for change, just copy them here. Okay, and the last row z is also same formula. New z will be equal to, take the old z plus, this is the pivot column element, minus 5, change the symbol, this is plus 5 into x1 new. Okay, so apply the formula same how we have done for the previous iteration. Now if you look at this one, again we are looking at this z row, 0 0 0 5 by 3 0 5 by 21, all of them are positive numbers. Once you got all of them are positive numbers, it shows that the process is completed. Okay, so finished. If you are getting a negative number here, again you should go for one more iteration, same method will be followed till you are getting all the numbers positive here. You should do it. Sometimes it will be looping again and again. In that case you can say the problem is not bounded, it is unbounded, there is no solution for that. Okay, that is also possible. So here we are getting all the numbers are positive, that means this is over. Now over means where is the answer. Take out this x1, the x1 value is from here 325 by 21, that is the value of x1. Then in the basic column x4 is there, so x4 value is 19 by 7. What happened to x3? There is no x3 here. If there is no x3, which means the value is 0. Okay, so x1 is 325 by 21 and x2 is 19 by 7, and there is no x3 here, so we can say x3 value is 0. Okay, so we find this step. But if you look at that, x4 and x3 are introduced by us, it is not given in the question, so we should reverse it back. What is x3 and x4? It is x2 is equal to x3 minus x4. This is the equation we used in the beginning. Now we can put x3 and x4 here, find what is x2. 0 minus 19 by 7 minus 19 by 7. Okay, so we got in this case x2 as a negative number. Okay, even at this stage sometimes you can get a positive number here, negative number here, even 0 also, it doesn't matter. Okay, so we got the value of x2, we got the value of x1. Once you got the value of x1 and x2, take the given question. So this is the given question. Now look at the objective function. The objective function is 5x1 minus 10x. Therefore the objective value is z equal to 5x1 minus 10x2. We have to replace this x1 value from here and x2 value from here. So x1 we have just now we have calculated, it is 325 by 21, and x2 we got minus 19 by 7. We have to substitute the values here, minus 10 into minus 19 by 7, 2195 by 21. Okay, just leave it as a fraction, no need to convert this into a decimal value. Okay, so this is the maximum value of the function. Okay, I hope you understood this problem. This is the method, almost everything is same like a simplex method, only the change is in the very first few steps, converting into a non-unrestricted variable into a restricted variable. That few steps are little bit different, but all other steps are just similar to our simplex problem. Hope you understood that. Keep learning. See you next video. This is signing off, Dr. C. Sudhakar.